Hello, everybody. I'm happy to be there with you online to present about what's new in Groovy 2.0. So first of all, a few words about me. So my name is Guillaume Laforge. I'm the Groovy project manager at VMware. I've been working on the Groovy project for the past, well, a fair number of years, 9 years or so. And I've initiated the creation of the Rails framework and also created the Gaelic toolkit for Google App Engine. I co-authored a couple of chapters of the Groovy in Action book, and there are a few links if you want to follow me on my blog, on Twitter, Google+, etc. Now let's focus on Groovy 2.0. So this is the bird's eye view. Hopefully it shows correctly on your screen. There are some issues with the shadows, but it's minor details. There are three big themes in the Groovy 2.0 release. We released Groovy 2.0 at the end of June, and we also released some minor versions up to 2.05 a couple of weeks ago. And let's have a look at what's inside. So first of all, let's speak about modularity. So if you take the Groovy all jar, as we call it, it's about 6 megabytes, so it's already quite big, but it contains quite a bit of things, because Groovy is not just a language, but it's also a set of APIs. And for example, you've got a template engine built in, you've got some classes for scripting and tasks, etc. And we thought that not everybody needs everything at all times. So the idea was to be able to pick up just the parts of Groovy you're interested in. So for example, if you want the template engine, you'll take the template engine jar plus the Groovy core jar. And similarly, well, with all the other modules. Now, by splitting the Groovy deliverables into smaller pieces, we have the big, the core jar, which is just 3 megabytes instead of 6. And while working on that split and modularity, we also introduced some interesting new feature, which is the ability to define your own extension methods inside of an extension module, and we'll see what it looks like. So you can still use the Groovy all jar containing everything, so you don't necessarily have to change anything in your POM file if you're using Maven or in your Gradle dependencies. You can stick with the same jar, but if you want, you can specify each individual jar. So we have different modules now. There are some modules for the tools, like the Groovy console, like the Groovy doc command, if you want to generate Javadoc commands for your Groovy classes. We also have, what other examples can I tell you about? Like, if you want to use the JSON support for producing JSON payloads or consuming JSON payloads, you can use the JSON jar, etc., etc. And the other aspect that I mentioned was extension modules. So while working on making Groovy more modular, we had to split our own jar into modules, and to do that, we also needed our modules to be able to contribute extension methods. For example, all the what we call the GDK, the Groovy Development Kit, that is all the methods that are added, for example, to various JDK types, like let's say the string method that we added called center. If you want to center a string for a certain length of string, etc. Those kind of methods are added by this mechanism, which we call extension modules or extension methods. So if you want to, for example, add a new method on the string class, like in this example, if you want to create an introduces method that you add to the string class, You cannot do that, obviously, in Java. In Groovy, we had already several mechanisms like Groovy categories, like expander meta class, if you're familiar with the Grails framework. It's often used in Grails, for example. And we took the same approach as with the Groovy categories. So you can create a class, here, string extension. We provide static methods. So all the methods you want to add are actually static methods on that string extension class. The first parameter corresponds to the type and instance you want to work with, and the remaining parameters are the parameters that are actually passed as parameters of the call when you are actually using this introduces method. So in the self variable, you have the Guillaume string, and in the string name parameter, you've got the string Cedric, okay? And this introduces method is going to return the G string that you see here, the interpolated string that you see here. Hi, Cedric, I'm Guillaume, okay? So this is exactly the same structure as Groovy categories. So if you know categories already, you can do, well, the same. It's really the same structure. So this example was for instance methods, but you can also create static methods. So for example, if you want to add a hi method on string, you do the same thing. You create a class, static string extension in our example. You create a static method called hi, and then the sole parameter that we have here is actually the type on which we should be adding the method. So here you can then call string.hi, and it's going to return the string hi, basically. So we created those classes, but now we need to reference them. So we need to tell the Groovy runtime how to discover those extension methods. So this is how we're doing that. We're creating a special file that we call the descriptor, the extension module descriptor, that we have to put in meta-inf services or Codehouse Groovy runtime extension module. For example, if you're creating a jar, you can put that file inside the jar, or as long as it's on the class path, Groovy will discover that method, that descriptor. In that descriptor, you're going to put a module name, a module version, and more importantly, the list, a comma-separated list of class names for the instance extension methods, and another line for the static extension methods. So this is how you can define your own modules that contribute additional methods to existing types. So if you want to enrich an existing type from the JDK, from third-party libraries, or even from your own jars, you can do so by creating your own extension module and defining those classes, as well as defining the extension module descriptor. So that's it for the Groovy modularity aspects. Now let's have a look at the Java 7 theme. There are actually two sub-themes, the Java 7 project coin syntax enhancements, which are syntax enhancements that have been added to Java 7. And we'll also speak a little bit about the InvokeDynamic support, which is a new bytecode instruction introduced in the JVM with the JDK 7, which is useful for dynamic language implementers to simplify the implementation of our language, as well as improving, excuse me, as improving the speed of dynamic method calls, etc. And in addition to the bytecode instruction, there are also various classes, APIs that we use internally for doing all those method calls, etc. So, first of all, we'll speak about the project coin enhancements. Since Java 7, and obviously with Groovy 2.0, you can use, you can define numbers with a binary form. That's why we call that binary literals. So you can define an int x variable with this notation, 0b, and then 10, etc. So you can properly see the bits corresponding to the int that you've just created. So it works for int, bytes, etc. Of the primitive numbers. So that's a new variant in addition to decimal literals, octal literals, hexadecimal literals. We now also have binary literals. You can also use underscores in your literals. For example, if you want to cleanly separate the 4 digits of a credit card number, if you want to separate the thousands and millions in for big numbers, or if you want to separate the bytes or words in a big number, you can do that, and you can put the underscores anywhere you want. Something I'd like to mention as well is that Groovy 2.0 still runs on JDK 5 and beyond, which means that all those syntax enhancements are also available if you run Groovy 2.0 on top of JDK 5. You don't have to run JDK 7 for that. But for the InvokeDynamic support, since it's part of the JVM, you'll have to run on JDK 7 to benefit from those additions. Let's continue with the project coin enhancements. With the Multicatch block, when you have try-coach control structure, not control structure, a block, sometimes there are different exceptions that can be thrown that are not necessarily inheriting from a common base class, well, besides throwable or exception, obviously. And sometimes you want to have the same treatment for 2 different kind of exceptions. For example, here, I want to do the same treatment in my catch block for IO exception and null pointer exception. So instead of having to, copying the 2 catch blocks and writing the same code in those 2 blocks, or using an intermediary method to factor the two pieces of logic. Now you can actually define 2 exceptions that you separate with the pipe symbol, the vertical bar. So you can say coach IO exception and or null pointer exception, and you just have 1 block to define what you want to do in that block. Now let's speak about InvokeDynamic. So Groovy 2.0 supports the InvokeDynamic bytecode instruction and APIs when you use Groovy 2.0 on JDK 7. For that, we actually created 2 different jars. So we have, I would say, the classical jar, which is the normal jar with the same kind of bytecode that we usually generate, but we also have a special Groovy Indie, short for InvokeDynamic. The Indie jar is the one you should use if you're running on JDK 7 and beyond, if you want to benefit from the runtime performance improvements brought by the InvokeDynamic support in the JVM. So if you want to use that, run on JDK 7 and beyond, and you can specify a compiler flag as well to specify that you want the InvokeDynamic support. The benefits of using InvokeDynamic, so generally speaking, there are some runtime performance improvements. So this is obviously interesting. And it's usually at least as fast as the current dynamic Groovy. And in some areas, it's faster, and we're still waiting for further improvements from the Oracle JVM team to further improve the speed of InvokeDynamic calls. And those improvements are coming anyway because the Oracle needs to use InvokeDynamic for the Java 8 Lambda implementation. So obviously, more performance improvement to be coming in further JDK 7 and JDK 8 updates. And what's interesting, but well, it's more, at least this part is more interesting for the Groovy developers themselves, in the sense that it will also allow us to get rid of our techniques that we've used so far to improve the speed of Groovy, like the call side caching techniques, etc. And we also had various internal structures to hold the meta classes, which is the runtime behavior of our classes. And well, so these are the various improvements that you can expect by using InvokeDynamic. And now the third theme is static theme, I would say, divided again into two parts. We are introducing static type checking as well as static compilation. So let's have a look at that. Static type checking first. So basically the idea is to make the Groovy compiler more grumpy and throw compilation errors, well, at compilation time, obviously, and not at runtime. And this is especially the case when you're integrating Groovy in a Java application, for example, and you want the same kind of feedback as the Java C compiler generates. So for example, if you make a typo in a method name, in a variable name, the compiler will complain right away rather than waiting for runtime for throwing some exceptions. So this also means that this is working for non-dynamic codes. For example, if you know about the Groovy builders and things like that, those are typically dynamic codes for methods which are not necessarily existing on the builder class, for example. And that means that you can use the static type checking on code which is, well, Java-like, but not necessarily using advanced dynamic features from Groovy. So Grumpy should complain about typos. It should also figure out things like wrong assignments or wrong return types when you return a type which is not compatible with the signature of your method. But it is also able to infer the types of your variables to know what kind of methods you can use and complete in your IDE, etc. And it should also understand all the Groovy development kit methods that we added. So although those features are definitely dynamic, they are not forbidden when you use static type checking. More concretely, let's take a first example with this little script here. So we have a method called method, and we also have a second method called test, which we annotate with the @typeChecked annotation. This annotation is going to trigger what we call an AST transformation, which will plug into the compilation process so that you can add, the Groovy compiler can add compilation errors when it makes sense. So here I have a method called method, but in my test method I'm calling method with some obvious typos, double T's, double H, triple O's. So there's something wrong there. Probably I have fat fingers or something like that, and or I fall asleep on my keyboard. And you will also see a local variable called name. And again, there's when I say a println name, I made a typo, a couple typos with double A's and double M's. And what's going to happen when you compile that class? It's going to throw two compilation errors on those two lines highlighted here, because the method called method with double T, double H, etc. cannot be found, but there's a method which actually exists, so that it's suddenly a typo. Same thing for the variable, and it's going to say that this variable is undeclared because it couldn't find a variable of that name. The annotation, I used it on the method directly, but if you have a class, you can put also the annotation at the class level. So it's a choice you can make. For example, you can mix and match, but I have a slide on that topic just afterwards. You can put the annotation on just one or several methods and have methods which are not type-checked, where you can use more advanced dynamic features of Groovy, for example. And you can also use type-checked at the class level, and then all the methods will be type-checked. And there's an additional parameter that I'm not showing here that you can pass to the annotation, which is skip, so that you can say, okay, I want to type-check the whole class, but for a certain method, I want to skip type-checking. So you've got the choice, class level, method level, and you can either compile everything statically, type-check everything statically, or skip certain methods. So it's a bit as you want. Then another example about wrong assignments. When you assign an object into a primitive type, like on the first line, the compiler is going to complain because this assignment is not correct. Or if you assign an object to a set, again, the types are not compatible. In the case of the array of string, you cannot assign an element of the string array to an int because a string is not an int. And also at the end of this example, of those snippets of code, you can see that I'm trying to add a string to a primitive type, and again, the compiler will complain here. So if I show you where the compilation errors will take place, the arrows will tell you where you'll get compilation errors. Okay, now about wrong return type. The method is type-checked. We have two branches in our if statements, so I'm going to return either a string or either an int. And the compiler will actually complain because I cannot return a string here, where you can see the little arrow, orange arrow. But on the other hand, for some Groovy code that is quite usual, for example, the second method called greeting, you see I'm using a string builder. I'm using the left shift operator to append some content to that string builder. And each append call actually returns the string builder itself. So the last expression which is evaluated is the one which is returned. It's a string builder. So you could think of that a string builder is not compatible with a string, but Groovy provides a coercion mechanism for that case. So if you've got a method which returns a string, classical Groovy converts the last expression to a string by simply calling toString. And for that kind of return values, the compiler won't complain because that's the kind of code that people sometimes write using Groovy, the usual dynamic Groovy, if you will. And speaking of dynamic versus type-checked, this is really about type-checking at compilation time, but the code which is executed at runtime is still the very same dynamic code that is generated by Groovy as usual. So this is the exact same behavior, but you have more checks done by the Groovy compiler. About type inference now, the compiler is also smart enough to figure out the types of things like your variables, your methods, etc. So here I define a name variable which is not typed. So the compiler is able to know that, okay, you assigned a string into that name variable, so that means we have a string in that variable. So later on in the gstring, I can say name to uppercase, and it will print, and it won't complain because we go to uppercase on an untyped variable because the compiler knows that this untyped variable actually contains a string, and to uppercase is, of course, an allowed method on string. The Groovy type checker also understands the Groovy development kit methods. So the trim method is part of the Groovy development kit, but it's not a method that you can find on Java long string. The type checker is happy with that. And also, in the last example, when you iterate over an array of ints, it also obviously won't complain about the fact that you say, okay, the int n variable from that numbers array is an int. So this is, I mean, it's figuring out properly the type of the variables, and it checks that the n is really an int because we define the array as being an array of ints. As I said a little bit earlier, you are able to say, okay, I want to type check a certain method, but not the other methods. So, for example, if you want to use a very dynamic feature like the markup builder to generate HTML content or XML content, you can say, okay, my greeting method should be type checked. So we check, you know, the variables, the method names, the types are correct, etc. But for the generate mark method, it's using a dynamic feature of the Groovy language. I don't want to type check that code so that the compiler doesn't complain because it doesn't know about an HTML method, a body method, a div method, etc. So this is how you can mix statically type checked code as well as dynamic code. You can separate that at least by using different methods, some being type checked and others being not type checked by not putting the annotation. Something which is quite verbose usually in Java is when you have a variable which is defined like just being an object, for example. When you have an instance of on that variable, so you say if val is instance of string, then you do something. Else, if it's instance of another class, you're going to do something. Usually in Java, you always have to introduce some temporary variable, or you have to use some additional casts, and casts are always needed in Java. But with the Groovy type checker, it understands that inside that if block or else if block, it knows the type of the variable because you checked for its class before. So you don't have to add useless casts. Also, it's going to figure out again the Groovy development kit methods. So since it knows that val is a number, I can call int value on it, and I can then also do the multiplication, which is a method from the Groovy development kit. Okay, next slide is about what we call the lube or lowest upper bound. When we speak about type inference, the static type checker is quite clever in terms of how it represents and how it knows about the types that you are actually using. In this case, our test method is returning a list of numbers. Here we have an integer and a big decimal. So we could think of the common type for that value to be a list of numbers. But actually, both numbers, although the base number class doesn't, both numbers also implement comparable. So the actual return type is a list of something which is a number and is as well a comparable. So this is quite fine-grained, and this is a bit more clever than what the Java type system can support. So there's no, the notation that you see here, list number and comparable, is not something that you can write in Java, nor in Groovy actually, but the static type checker figures out that the type is, I mean, you can call methods like compare to on the elements of that array, of that list. So this is the tube, and since we have type inference, there's also a case, well, which is usually not a very good coding style, but sometimes people use variables to hold different values of different types. Our variable here contains an integer. Then later on we'll assign a string. And when we do x equals var to integer, the static type checker knows that at this point of execution, the variable var actually contains a string, so we are allowed to call toInteger, because toInteger is a method that Groovy provides on strings. Oops, sorry, I went too far. But for the last call, we reassigned a number into the variable, and since the variable is not a string anymore, you're going to get a compilation error because you can't call toUpperCase on a number, because toUpperCase is a string method. And now let's speak a little bit about the gotchas. So I mentioned one already, which is the fact that you cannot use all the dynamic features of Groovy. So things like metaclass changes, like Groovy categories, objects like classes like the markup builder, the various builders cannot be used in the static type checking part of your code, because the checker cannot really know at compile time if those very dynamic calls are actually correct or not. So it's going to complain when you use those dynamic features. So instead, when you want to use these dynamic features, don't type check those particular methods. But otherwise, the behavior of the code which is type checked is the very same as the usual dynamic behavior. So this is actually different from the static compilation, where the behavior might be slightly different in a few corner cases. And also, but it's not a gotcha, you can also use all the AST transformations. So that's what we also call compile time metaprogramming. So if you want to use transformations like @delegate or @immutable, etc., or @toString, =an hashcode, etc., you can always use those transforms. They are perfectly well understood by the type checker. About the runtime metaprogramming aspects, if you want to use the expander meta class, and you'll get a problem here because meta class is a dynamic property. So the static type checker will complain, saying this property is not known. And since you couldn't actually add the method, and you cannot do it, cannot figure out at compile time, it will also complain on the foo method that you thought you just added with the expander meta class just above. So the static type checker will complain here. There's also a little gotcha with methods like collect on collections, because here here it's a case which is quite explicit, but the list that you have here could be coming from a parameter or from elsewhere, from the return type of another method, etc. So the static type checker cannot always know on what kind of elements it's going to work inside that iteration, in that collect iteration. So here, instead of saying collect it to uppercase, you have to explicitly define the type of the closure parameter. So you can say string it or string s arrow it s or it to uppercase. So in order to actually help the static type checker. And we're working on some solutions to allow us to avoid typing like we just did here. So sometimes, like in this case with some methods like collect on collections, you may have to help the static type checker by adding some additional type information to get the most useful feedback from the type checker. If you remember what we said about the flow typing and the type inference, when the type checker is able to follow what we assign inside a variable, but there's a special case where like in this example, I assign a string inside a variable, and then I have a closure which may or may not assign some other values inside our variable. But the thing is that the static type checker cannot always know whether the closure was called or whether it wasn't called. So for example, if we have some random condition, like math random or something like that, perhaps the closure will be called, perhaps it won't be called. So the variable may hold a string or it may hold a date. So if you want to do var to uppercase afterwards, it means that you're expecting you're going to get a string there, but the static type checker doesn't know. Perhaps it'll be a date, perhaps it'll be a string. So the compiler will throw an error here because it cannot figure out if it's a string or a date. And the loop, the lowest upper bound, is it knows that it's something that is an object which is comparable, I think, because both strings and dates are comparable. But it doesn't know that it's a string, so it doesn't know that there's not two uppercase method. But for example, for the case where you have A and B and class B extends A, if you assign A an instance of A and then later on assign an instance of B, you know that at least the variable will contain something which is of type A or subclass of A. So if you want to call method foo, since it's on the base class A, you are allowed to do that, and the static type checker will be happy and it will not complain. It's at least an instance of A. If you had tried to call bar, obviously it would have complained because the closure might possibly not have been called, and then you wouldn't have it be there. Static type checking, so you can also think about why not compiling that code just like the JavaC compiler and do, well, what we call static compilation. Given the code is type checked, after all, we could really, just generate the same kind of bytecode. So if we especially wanted to provide a solution in terms of performance for people who are not always allowed to use JDK 7 in production. Lots of companies still use JDK 6. So if you want to benefit from the performance improvement of the InvokeDynamic support, you would have had to use JDK 7. But even if you run on JDK 5 or 6 or 7 and beyond, you can get some performance improvements if you use static compilation. But we needed the static type checking support so that we have enough type information to be able to generate the same kind of bytecode as the Java compiler. So that's actually what we did. And what do you gain with that? Well, obviously you have the same kind of type safety as with static type checking, because static compilation is using the static type checker under the hood. And since you do static compilation and generating more or less the same kind of bytecode as Java, you get faster code, as fast or almost as fast as Java. And another benefit, since the code that we actually generate, the bytecode we generate, is actually not going through the meta-object protocol, which is the dynamic heart of Groovy, your code is actually immune to monkey patching. Monkey patching happens when you use runtime metaprogramming techniques and when you change the behavior of some methods, some existing methods, or new classes, or third-party classes, etc. So this is also a way of making your code more secure if there are parts of your library, your business rules, etc., which needs to be immune of any metaprogramming modification. And also another gain is about in some circumstances, you can also get some smaller bytecode. So if you care about the size of your classes and jars, this is also a benefit. So what does it look like? Oh yeah, before speaking about what it looks like, the disadvantages. So just like when you use static type checking, you lose certain dynamic features. So meta class changes, categories, Groovy builders, etc. All those things are not allowed because they are inherently dynamic, and the Groovy compiler cannot really wire the method calls because it's about calling, non-existent methods, etc. There are also some cases where the behavior might be slightly different than pure dynamic Java. This is the case when you have multi-methods. In the case you have overloaded methods with different types, etc. Groovy, dynamic Groovy, usually figures out the method to call at runtime depending on the runtime type of the parameters the method is passed with. And here, since we are generating this bytecode at compilation time, we cannot know at runtime what the type of the parameters will be. So thanks to type inference, we actually usually know quite well which types are used for the parameters of your methods. So in most cases, you'll have the very same behavior as dynamic Groovy, but in some cases, you have to be aware of the fact that if you have parameters like object foo, the static compiler doesn't know much about the type of your parameter. So it's better to provide more type information so that the type inference can kick in so that you get the very same method dispatch as with pure dynamic Groovy. And what does it look like? You remember the markup builder example that we used earlier with @type_checked. Here, instead of using @type_checked to trigger the static type checking, you can use @compile_static, a new annotation, to do the same thing. The annotation, just like type checked, can be put on methods and on classes. On classes, that applies to all methods inside your class, but you can also use the skip annotation parameter to say, okay, I want to skip static compilation for a certain method, so that you say, okay, this one should be dynamic. So it's your choice. Either you explicitly say compile static on every method, or at the class level, and you can decide what should be dynamic, etc. So it's a bit, a question of taste, or depending on the structure of your class. If you've got tons of methods in your class, perhaps you want to use the annotation at the class level and just have one method where you skip the static compilation. And what about performance? So we made some measurements with some micro benchmarks. So be sure to, well, micro benchmarks don't necessarily represent the actual kind of code that you have in your application. So you'd better always measure the performance hotspots in your application rather than relying on micro benchmarks. But when we were developing those features, we obviously needed some benchmarks so that we knew that we were doing things well. So we used some micro benchmarks there. And as you shall see in the next table, I used different versions of Groovy on 3 different micro benchmarks. So I used 3 benchmarks, the Fibonacci series example. The second one is the pi quadrature calculation, which is an approximation algorithm for calculating pi. And the last one is a binary tree. It's a little algorithm for searching in trees. I tried the very same code with Groovy 1.7, Groovy 1.8, Groovy 2.0, and Java. I didn't try to optimize the code so it looks more groovy. So instead, I used, so I don't show you the examples there, the implementations here, but the code looks very Java-like because I didn't want to cheat on the micro benchmark in case we have some, more optimized solutions in a pure Groovy solution. Instead, I wrote pretty much the same code as the Java version. In Groovy 1.7 and prior, we had no particular optimizations beyond the call-side caching techniques. And in Groovy 1.8, we introduced some primitive calculation optimizations. So when your code relies on primitive calculations, if you're doing lots of calculation and number crunching in your application, Groovy was really pretty slow in Groovy 1.7 and before. But since Groovy 1.8, the performance was really pretty close to the one from Java. But in Groovy 2.0, with static compilation, we get pretty much the same kind of performance as pure Java. So in the Fibonacci and pi quadrature examples, it's pretty much the same performance, a little overhead. In some other examples, like the binary trees micro benchmark, we're about 20% or 30%, yeah, something like 20% slower than Java. So it's a very good level of performance, and obviously in further releases we'll continue to streamline the bytecode we generate, etc., to try to get the best performance as close as Java as possible. Here in this table, I'm not showing the InvokeDynamic support, but you would get more or less the same results as probably the primitive optimization line, and probably a bit better for the binary trees example, though, because the dynamic method calls will be faster with JDK7, if you're running with JDK7 and the InvokeDynamic bytecode instruction. So very good performance if you use static compilation, and even since Groovy 1.8 with the primitive calculation optimization that we introduced. So that's about it. The big themes of Groovy 2.0 were the modularity, how we split the Groovy jar into different modules, and which opened the door for what we call Groovy extension modules, so that you can contribute additional methods and doing operator overloading, etc., by providing your own extension methods. What's also interesting that I didn't mention was the fact that static type checking and static compilation definitely understands those static methods and instance methods added through the extension module descriptor. So you can have dynamic features like expander meta class, categories, etc., but statically type checked and statically compiled. That's also a nice benefit, and also a reason why we introduced extension methods. With the JDK7 theme, we introduced the project coin syntax enhancements, like the multicatch, like the binary literals, the underscores in number literals. And we also added the InvokeDynamic support so that you can get better performance if you're using JDK7. And next and last, the static aspects with the static type checker to get the same kind of feedback as the JavaC compiler and beyond. And also static type compilation to get performance improvements and getting almost the same kind of level of performance as with the JavaC compiler. So thanks a lot for your attention, and I'll be taking some questions in the Q&A part. So if you want to ask some questions, feel free to do so. So sorry again for the little interruption. So let me have a look at the various questions that we have already. So yeah, for the once again, the session is actually recorded, and in a week or two you'll find the video on the YouTube channel, on the SpringSource Dev channel. And I don't have the link handy, but if you just do a Google search for SpringSource Dev channel YouTube, you'll find it easily, and you also think you can also find it from the springsource.org website. So that's it for that question. The static and extension words are conventioned. So when we define when we write the extension module descriptor, so you remember we had two 2 lines, one line for defining the list of classes which contain the extension methods and instance methods, and another one with the list of classes which contain static methods. The best practice would be to define different classes for the different types you want to enrich, but you can very well, if you have a limited set of new methods that you want to add, you can very well just put the all the methods, the extension methods, inside one class. But if you want to have static methods and instance methods being added to your types and instances, you have to do that in 2 different classes. Okay, so you'll always have, if you need both instance and static methods, you'll always need and have to have 2 different classes, one for instance methods and one for static methods. So you like the multicatch feature? That's cool. And what's also nice, by the way, about the project coin syntax enhancements is that you don't need to run JDK 7. Even if you run Groovy on JDK 5, you'll get all those JDK 7 enhancements, syntax enhancements. So if you want to use the multicatch, the binary literals, the underscores in your numbers, you can do that even when you run Groovy 2.0 on top of JDK 5. So even if your production environment doesn't yet run JDK 7, you can very well use those syntax enhancements there. Why type checked instead of the inverse unchecked? Well, that's a good question. We went with type checked because usually, Groovy by nature is a dynamic language, so most of the time you'll be happy to use the various dynamic features offered by Groovy. So we felt it more natural to actually type check only when requested. And also because if we had decided to say everything is type checked, then for classes that were compiled with Groovy 1.8 and before, you would get some compilation errors because things suddenly get type checked with Groovy 2.0, although they were not type checked with Groovy 1.8. So in order to avoid breaking compatibility, we preferred adding the option of type checking rather than having to specify unchecked, so you didn't have to recompile everything. And we've put the link of the YouTube channel in the QA part that you can see. So it's youtube.com/SpringSourceDev. What else? So from the perspective of code security auditing, is it possible to do runtime tests to see if code is statically compiled? Runtime tests. Well, it depends what you mean by runtime tests, because you cannot really introspect the bytecode at runtime easily. So I'm not sure. Well, we have some. I don't think we can do runtime tests for that. I'll have to think about it more deeply. That's an interesting question. I'm not sure we can actually do a runtime test for checking that things are statically compiled. What else do we have? Yeah, so can Groovy 2 be used with the current version of Grails? So if you use the latest release candidates for Grails 2.2, yeah, so I think it was the RC one, the latest release. I don't remember the very last release of Grails. If you use those release candidates, they are actually already using Groovy 2. The Grails versions prior to that, well, the current official stable branch is still using Groovy 1.8, So you cannot yet benefit from all those Groovy 2 features yet. So you'll have to use the newest version of Grails, which is going to be Grails 2.2. What is the annotation to not apply type checking on a method? So if you want to skip type checking, you're going to do @type checked, and you're going to pass the skip enum value from the type checking mode enum. So you have to import type checking mode, and so this would look like @type checked parents type checking mode dot skip, or if you used a static import on the enum values, it would be @type checked skip that you would write. Do we have any helper tool to identify code that can be annotated static compile? Well, no, we don't have such a tool, but usually you can progressively annotate classes or methods with @static compile, @compile static, so that you can see whether the compiler is happy or not. So I cannot really tell you. There's no tool to tell you, here are all the places where you could use static compilation. So it's a bit of a trial and error approach. You progressively add compile static annotation where it makes sense. Usually the performance of Groovy is usually very good, but it's really where you notice there are hotspots that you should be looking into adding something like @compile static. So first of all, be sure to measure the performance of your application, and try to find whether there are some hotspots and whether those hotspots are actually coming from your Groovy code. And if it's coming from your Groovy code, figure out what can be done to improve things. And one way, obviously, being using the @compile static annotation. For extension modules, is it possible to do this if we are running dynamically and don't have the opportunity to modify any meta-inf files? Well, the Groovy runtime looks for meta-inf files. So really, extension modules are the purpose is really about helping static type checking, leveraging static compilation, etc., rather than really replacing all other mechanisms, and especially all those dynamic metaprogramming mechanisms. So you should probably, use, well, when you cannot register at runtime, but you should really think of that approach as being something that's done, it's not that it's done at compile time, but it's something that should be done, I don't want to say the word statically, because it's not really about static stuff, but it's about something that is not supposed to be dynamically done, like this is the case with Expondo metaclass and so on. Well, about the timelines on when Grails will move to Groovy 2.0. As I mentioned, Grails 2.2 will use Groovy 2.0. I don't think Grails 2.2 is very far away. I don't have the exact date in mind, but it's not going to be in a long time, so it's going to be pretty soon in terms of weeks or months, probably. How InvokeDynamic JVM instructions speeds up Groovy execution. I don't want to enter into the technical details of InvokeDynamic, how it really works at the JVM level, but it's a new bytecode instruction, and the JIT compiler is able to figure out that certain paths can be sped up in terms of method calls. So it's a way of speeding dynamic method invocation rather than going through our usual runtime techniques, the runtime heart of Groovy to do the dynamic invocation. So can you know if, again, about extension methods, if you want to know if the string class was extended or not, So if you use static type checking or static compilation, you cannot really figure out. But if you're using non-type checked code, you can still call string.metaclass.response to. So it's part of the metaclass API. So you could figure out if a method is there or not. Yeah. So are there plans to add type checked and compiled static at the class or package level? At the class level, yes, you can already do that. So you just put @typechecked or @compiled static at the class level. So @compiled static class foo. At the package level, it's a bit tricky because of how you actually get the annotation from the package. And there are a number of cases where you couldn't know that the package was supposed to be type checked or statically compiled because we couldn't get the annotation. And there are also some problems if you use incremental compilation. For example, if you're using the Eclipse compiler, IDE and its compiler. So that's why we didn't do it at the package level. We might revisit that if we find a good solution, but so far, since we cannot be sure that it can work in all the possible cases, we didn't do that so far. And then, yeah, so will this presentation be available on SpringSource Dev? Yes, it will be available in a week or two. The presentation will also be available. And you can also have a look at slideshare.net/glaforge. That's where I often put my slides. And if you look at my latest presentations, you'll find the slides there in another format already. Okay, and one last question. Is there a global setting like -d compiled static equals true? Well, currently not, but we're investigating some options for being able to apply some AST transformations. So we might provide something, but currently there's nothing available. Well, that's it. I've answered all the questions. So thanks again for your attention, and it's been a pleasure to have you having you all on board of this webinar. So I'm looking forward for your feedback. Don't hesitate to contact me, and I'll be happy to answer further questions. Thanks a lot, and goodbye, everybody.